Okay, then Maddox can have a turn. And that's the last show. Okay, sorry. This is, oh, you can't see me. This is an explanation of your virtual lab. So first thing you need to do, click on the link. I hope that you guys will be able to just access the Google Doc and write on it. I know that some people had difficulties with that last time, so if you do, shoot me an email and I'll try to make an adjustment. Okay, so the first thing you're going to do is pick a metal and then you're going to test it. So put the strips in. Click to remove. And you're going to record what they look like in your data table. Oh, I want to mention, I was just on here, so the flash is working, but if you need to change and enable flash, you can go to settings, and then there's a button that says flash, and make sure to allow it. Okay, so next thing you're going to do, let's go back to your lab. Is based on what you wrote in your data table, you're going to organize your data for the most active metal and the least active metal. So you should see like one of the metals reacted the most and one of them didn't react very much. So you just want to put them in order from most to least, just like table J. And then based on location of your metal in the activity series above, which metal is most likely to be oxidized. So based on where it's located, like table J, so this is in your notes on table J, which metal is most likely to be oxidized. And then part 2, you're going to click on the link. Again, make sure to enable flash if it's not, so go to the little lock button, go to site settings, or it might be up here. It's probably in site settings. Okay, so it tells you in your lab what to do in the left beaker and in the right beaker. So the left beaker is the red one, the right beaker is the black one. So pick your metal, so silver, pick your solution, silver nitrate, pick your metal, copper, solution, copper nitrate, and then hit on. And it's gonna run, so just let it run. And you should take note of the voltage. You need to record that in your data table, and you need to record the direction that the electrons are flowing. So from the right beaker to the left beaker. For one of the questions, it's going to ask you to look at the molecular level. So if you let it run, then you'll get this option to look at the molecular level reaction. So this one, you can see that your silver ions are meeting some electrons, and then that's the reaction. You can play it again if you need to. On this one, copper is losing some electrons and changing to copper ions. Okay, so back to the lab sheet. In your data table, I gave you what should be on the left and the right. So I just did trial 1 with you. So you're going to record the voltage and then the direction of the electron flow. Trial 2, these are the metals and the solutions you should pick for each one, and do the same thing, voltage from what to what. Okay, so in the analysis, given the flow of electrons, which beaker, the left one or the right one, is the anode? So you should look at the direction of the electron flow to figure that out. And number 2, where does oxidation occur, at the anode or cathode? And then number 3 might be tricky. You're going to write the half reaction that occurred in trial 2. So based on which one you said was the anode and the cathode, you should be able to write this reaction. So the anode, remember, will start as a metal and change to its ion. So I gave you what the possible ions are. So it's either silver plus or zinc 2+. The cathode starts as the ion and goes back to the metal. There's a couple problems like this on the pages, I don't remember what pages they are exactly, but they're the pages that have the 4 voltaic cells, and you had to do like one additional thing each time. So if you need some examples, that's where that is. And then choose one of your trials and look at the molecular level. So that's what I just showed you. Describe what happens to the size of each electrode, like it got bigger, it got smaller, and why. And be specific about what you see. So you can't just write it got bigger, you have to say because blah, blah, blah. Turn to blah, blah, blah. So make sure that you do that for anode and cathode. Okay, so I think that should be enough to get you going. I'll be on Zoom Monday at noon. If you need anything Tuesday, shoot me an email. Okay, and